We're going to continue with chapter 4, talking about different types of sampling techniques. You'll notice in the notes there's an activity. We're going to go through that activity in class. So let's keep going on to the next page. And a discussion of what a stratified sample is. So when we're talking about a stratified sample, what we're going to be doing first is we're going to classify the population into similar groups, which we call strata. Oops. Then once we do that, step 2, we're going to take an SRS, a simple random sample, from each strata. And we're going to combine these SRSs to form our sample. So here's the idea of a stratified sample. We have our population. Maybe it's all South students. Okay? In a stratified sample, we now divide up the population into groups based on some characteristic. So for example, something that might be good is grade level. So I'll put 9th, 10th, 11th, and 12th. And then what do? I take a simple random sample from each of my grade levels. So the difference between a stratified sample and a simple random sample is in a stratified sample, you're taking your population and you're breaking it up based on some type of characteristic, a characteristic that matters, okay, to what you're trying to do. So for example, I want to know what percentage, think about in a regular school year, what percentage of kids are going to go to the homecoming dance? Well, I don't want to take just a simple random sample of all South students by putting, everybody's name in a hat or using student ID numbers and randomly selecting 100 people. I want to ensure that I get representation from each grade level because I think the grade level might impact whether or not you go to the homecoming dance. So instead, I could use a stratified sample, divide it up based on grade level, based on that characteristic that matters, and then take a simple random sample from each of the grade levels. You see this type of sampling technique all the time in different type of polling that's done, okay? Say for the election. I want to ensure that I get representation from each different area, say in a state, or on different races, or different political parties. So I don't want to just take 100 people. I know I should get this blank percentage be Democrat, this blank percentage be Republican, so I might divide my population based on political party and then take a simple random sample from each political party. So the benefit of a stratified random sample is that it's more representative. Okay? And it provides a more precise estimate. Of whatever we're trying to estimate. Okay? There's less variability in a stratified random sample. So how do you choose the variable to stratify on? You want to pick a variable that matters. What do we mean by that? We mean pick one that is the best predictor So for example, if we go back to our homecoming problem, and I want to estimate the percentage of students that are actually going to go to the homecoming dance, right? I could stratify on all types of things. I could stratify on shoe size or hair color or eye color. But do those things really make a difference in the percentage of people that are going to go to the homecoming dance? It's not like I think blonde-haired people are more likely to go than brown-haired people. But I do think that grade level might impact whether or not you go. So it would be a lot smarter to stratify based on grade level than based on shoe size or hair color or something like that. Maybe you think that their location in the town or distance from south may impact whether or not they want to go to the homecoming dance. So something like that could be something that'd be useful to stratify on. I'll stratify based on your elementary school that you went to, because I think people that live in the Nut Swamp or River Plaza area might be more likely to go because they live closer to south. Okay, that might be a variable that would be useful to stratify on as well. But the important thing on what a stratified sample is you've taken your population, you've divided it up into subgroups based on some characteristic, and then you've taken a simple random sample from each of those subgroups. We'll look at the next example in class. So although a stratified sample can sometimes give more precise information about a population, it's hard to implement a stratified sample because you have to do a bunch of simple random samples, which we already know are tedious and difficult to do. Okay, so those sampling methods are especially hard to use when the populations are large and spread out. In that situation, we'd prefer a method in which we select groups of individuals that are near one another. So this type of sampling technique is called cluster sampling. So to get a cluster sample, start by classifying the population into groups of individuals that are located near each other, called clusters. Then choose an SRS, again a simple random sample, of however many clusters you need. And the key thing in a cluster sampling is that all of the individuals in the selected cluster are surveyed as a part of your sample. So let's go back to our example and think about how we can do a cluster sampling for the percentage of students who are going to attend the homecoming dance. So once again, I have all of my students here. But this time in cluster sampling, you almost always divide them up based on location. So I could divide them up based on maybe what classrooms they are in the school. So maybe the classes 100 to 120 would be one of my clusters, and maybe 120 to 150, and then maybe 150 to 170, and then maybe I'll do 200 to 220, and maybe 220 to 250, and so on. In cluster sampling, you take, okay, I've got these 5 clusters. I'm going to randomly select, depending on how many people you want to survey, maybe 2 of the clusters. So you take a simple random sample, and you randomly select 2 of the clusters. Maybe this cluster and this cluster are selected. And then within those clusters, everybody who's in that cluster gets surveyed. So all of the people here are surveyed, and all of the people here are surveyed. Nobody from the 120s to the 150s, 150s to the 170s, or 220s to the 250s are surveyed there. Cluster samples are good, okay, because they save time and money, and it works best when the cluster looks like the population just on a smaller scale. So I wouldn't want to cluster based on, say, okay, maybe all of the AP classes are in this portion of the building. Well, I wouldn't want to cluster based on that because then my cluster is not representative of the entire population. So you want to make sure that your clusters are like mini versions of the population when you're dealing with that. Again, we'll look at more examples and go through all of the different types of techniques and examples during class. The final thing that we have to talk about is inference for sampling and bias. So the purpose of a sample is to give us information about a larger population. The whole reason that we're taking a sample is we want to try and make some type of inference, aka prediction, for the entire population. The process of drawing conclusions about a population on the basis of sample data is called inference. So we have two real portions in statistics. We have what's called descriptive statistics and inferential statistics. Descriptive statistics is the actually collecting of data, showing what we've gotten in our sample. Inferential statistics is the real fun part of statistics, where now you can take that data that you've gotten and make some type of inference, prediction, conclusion about the broader general population. So why should we rely on sampling, random sampling? To avoid bias in selecting samples from the list of individuals. The laws of probability also allow trustworthy inference about the population. Results from random sampling come with what's called a margin of error. That sets bounds on the size of the likely error. Larger random samples give better info about the population than smaller samples. And you'll see this term margin of error all the time. We're so close to an election. You see a poll come out. It has Trump at this value, Biden at this value with a margin of error of blank. We're going to talk a lot about this in class and look at lots of different polling to see what the margin of error is and what it actually means. So when we're talking about margin of error, it represents how far we expect the sample proportion or mean, depending on what we're talking about, to be from the population proportion or mean. Okay, key thing here about margin of error. It accounts for variability, not bias. So when we're talking about, okay, there's a margin of error of plus or minus 4 percentage points. When we're taking a sample of, say, 1,000 people in the US and we're trying to estimate what the actual percentage that's going to vote for each candidate, there's a margin of error because just because I got 48% in my sample proportion, even if I've taken the greatest, most representative sample of all time, that doesn't necessarily mean that it's going to be exactly 48% for the entire country because you're only taking a subset, a small sample of the population. So there is going to be variability. And say I take, using the same exact sampling technique, another different sample of 1,000 people. I might get a different result because there's going to be variability in your smaller samples for the entire population. Now, with that said, the benefit of increasing sample size is that it increases the precision. Not necessarily accuracy, but it increases the precision and reduces the margin of error. So the larger the sample size, the more precise your estimate will be. Now, say you've done everything right. You've taken a great sample, you've used a great sampling technique, you've taken a simple random sample or a stratified random sample, you've used one of the great sampling techniques. There's still things that can go wrong. So most sample surveys are affected by errors in addition to sampling variability. So good sampling techniques includes the art of reducing errors. So even if we do everything great, there's still the possibility of certain errors occurring or certain biases occurring. The first of which could be undercoverage. Undercoverage occurs when some members of the population cannot be chosen in a sample. So for example, say we're polling people for the election and we only use those listed in the telephone book. Many years ago, this was a major issue with polling, okay? Because they only used to use people whose phone numbers were listed in the telephone book. Well, nowadays, there's so many people who don't have home phones. They only have a cell phone, like me, okay? Well, those people were being left out as potential people to be a part of the sample. All right, that's an example of undercoverage. We're leaving those people out. They have no chance of being selected. Well, all of those people tended to be younger voters or something like that. They might have been more likely to vote in a certain manner, and we've left them out as a part of our sample. That's an example of undercoverage. Non-response is a major issue. Non-response occurs when an individual chosen from a sample cannot be contacted or refuses to participate. We're going to take a look at this in class at some of the non-response rates for polling that we see because people just don't want to participate. Or they say, hey, I'm doing a poll for this, and they immediately hang up the phone. This is a major issue in polling, and one of the things that you'll notice is that polling companies or people who are doing polls will frequently call back to try to reduce the non-response rate because they want to make sure that their sample is representative. One of the most important ways in which things can influence people's answers is the wording of the question. The wording of the question is an example of a response bias. And you'll see there could be polls that come out the exact same time, but a slight change in the wording of the question can impact the way that people respond. That is an example of a response bias. Okay, there's different types of ways that we can have response biases. A response bias is a systematic pattern of incorrect responses. And a response bias is one of the most common types of bias or errors that we can see. So we have errors in design method, which means the way that you've obtained your sample, which we talked about last class, which could be something like convenience sample, or a voluntary response sample. Okay, these are designer flaws. But then you can have errors causing response bias, which are other ways in which our results could kind of lead to something that might not be accurate. All right? So in response bias, people lie. Okay? They don't tell the truth, and there's different reasons as to why. It could be the wording of the question. How the question is worded has a major impact on how people answer. Okay? The second way is the type of question that's being asked. So for example, sensitive type of questions such as, do you smoke? Have you ever had an affair? Okay? You're never going to get accurate results on that because people are kind of ashamed to maybe admit something like that, and therefore they lie and they don't give you an honest answer. Another type of way that you can have response bias is based on who is asking the question. All right, if I'm asking you, have you ever cheated on a test, you might not answer the same way as if one of your friends asked you that. Another type of way, we lost a triangle, but I'm going to add one, is it anonymous or not? If I ask you, did you brush your teeth today? And I have you do it with everybody looking at you, and then I have you do it anonymously, you might answer differently. Okay, so you always have to think about when you're talking about a response bias, all right, how is the way that I've asked the question, or is who's around me, or something like that, going to influence the people's responses? And all of these things are examples of ways that we can create a response bias. Last thing, just to kind of go through here, is a common error that we see. So on the AP exam, many students lose credit when describing what can go wrong in sample surveys because they use the wrong terminology. So make sure that you're using the right terminology. To be safe, don't worry about naming the exact error. If you think it's undercoverage, you don't necessarily have to do that. Instead, just clearly describe the error in the context of the question. The explanation is especially important, since just correctly naming the error will often result in no credit anyway. So don't just focus on I gotta memorize what this error is and this bias and so on and so forth. Understand the concept of them. And every time that you're asked to describe a bias, it's important that you describe the direction of the bias. So this has caused this to overestimate the percentage of people who blah, 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 or underestimate. So describe the bias in the context of the question, and then describe what that bias is leading to, okay, how it's affecting our responses. Some interesting stuff here, especially given where we are in terms of an election. I'll see you in class.